Hi guys, making you this video as a little refresher of chi-square since we are going to be doing these problems for your FRQ this week. So I just want to do a little practice problem. The FRQs that you have will on the AP test probably be a little more complicated than this, but at the same time it will be the same procedure. So you'll be able to do it and it'll be great. Alrighty, so we start with a problem up at the top. It tells us how many total grains of corn there are, 433. And then it breaks it down to the different phenotypes that are visible. So right now, you already know that this needs to be a dihybrid cross, which is a 16 square Punnett square. Because if you look at the traits, it says things like purple and starchy or purple and sweet, which means there's two different traits going on there. So right off the bat, you are going to need a 16 square Punnett square. This one's really nice because it tells you straight up right here that you're going to expect a 9 to 3 to 3 to 1 ratio, which is always going to be true if you find that you have two heterozygous individuals as your hypothesis. But sometimes you will not find that, and so you have to actually solve the Punnett square. So what I'm going to do is solve the Punnett square so that you can see how I would do it in case you need it. So you'll have your 16 squares. And you're going to have your different possible gametes that each parent could give, so the sperm or the egg that each parent could give, going across the top and down the side. So, for example, this parent could give a big P and a big S, a small p and a big S, a big P and a little s, or a little p and a little s. And those are the same possibilities going down the side. Okay. And then when you fill in these sorts of squares, you fill them in by keeping your same letters together because those are the same alleles. Every individual has two alleles for a trait. So that means this is going to be two big letters for each. This is going to be big P, small p, two big S's, two big P's, big S, little s, big little, big little. And then I'm just going to keep going through this. The nice thing is on the AP test, if you were trying to save time and you knew the ratio, then you wouldn't even have to do this square, which would be great. So two heterozygous parents is always 9 to 3 to 3 to 1. But if you get tripped up and you're like, I just need to do the square, this is how you do it. Also, if the parents are not heterozygous in the hypothesis, then it's not 9 to 3 to 3 to 1. So you might need to do the square for that also, anyways. Two little s's. Little, 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 little. Okay. Now you can see here that you end up with the same ratio that it told you that you were going to end up with. So you have 9 that are dominant for both traits, which I'm highlighting now. And you have 3 that are recessive for one of the traits, be these 3 that are recessive for P, color. And then you have 3 that are recessive for the other trait, texture or sweetness, I guess. And then finally you have your little one that is recessive for both. So now we can use this to get our expected values. Oops, that's really thick. Make it smaller. So expected, we're going to go back up to our total. So we're going to use our ratios that we expect and our total number of corn kernels to figure out how many of them, if it was a perfect world, should be each of those traits. So for our purple and starchy, you would expect 433 times 9 out of 16. For your purple sweet, you would expect 433 times 3/16. Same thing for yellow starchy, 433 times 3/16. And then finally, our yellow sweet, we would expect 433 times 1/16. So now I'm going to go ahead and use my trusty phone calculator to get those numbers. If you do use like a basic calculator, do the fraction first. So I'm doing 9/16 equals, and then I'm doing that times 433. So that will be, you can round for these. So I got 243.56. I'm going to round to 243, no, 244. The reason you round is because you wouldn't have half of a corn kernel that was purple and starchy. So you can just go ahead and round. If it's like rats or whatever, also, you would round to like the nearest whole rat. All right. So then for, 3/16 equals times 433 is 81.1875. So I'm going to make that 81. This one, 81 also, because it was the same. And then finally, 1/16 equals times 433 equals 27.06. So that will be 27. All right. So now it's time to actually do our chi-square. So what we're going to start with is our observed minus expected. So I'm going to make a little thing here that's O minus E. When you do this on your test, you do not have to show like all of these different breakdown steps, but I'm showing it so I can show you how I get to the answer. So our observed minus our expected for purple starchy, that's 277 minus 244. Then we have our 75 purple sweet minus 81. Then 63 minus 81, and finally 18. So 18 minus 27 for yellow and sweet. Then you can go ahead and solve those. Some of the values are going to be negative. So 277 minus 244 equals 33. 75 minus 81 is -6. 63 minus 81 is -18. And then 18 minus 27 is -9. All right, so now we can square those values. So square all of them. Equals, 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 equals. So we'll do 33 squared is 1089. -6 squared, doesn't matter that it's negative anymore because you're going to square it. 36. 18 squared is 324. And then we have 9 squared, 81. Okay, so this was squared. O minus E squared. Okay. Now what we're going to do is we're going to take this and we're going to divide by our expected value. So this is going to be O minus E squared divided by expected. Okay, so we're going to divide this by 244. We're going to divide this by 81, 81, and 27. Okay, so now we have 1089 divided by 244. Going to be 4.46. And on this one, I don't round until I get to the end. It's really 4.46311,475, but you can round more than that. I usually do 2, 3. All right, so then 36 divided by 81 is 4 repeating. 324 divided by 81 is 4. And 81 divided by 27 is 3. Then the last thing you do is you sum all of these together. And that's this symbol on the formula. So we're going to take our 4.46 plus 4.44 plus 4 plus 3. And we're going to get 11.9. And that's equal to chi-square. So that's your answer. But then what you have to do is you have to go and look at your table for chi-square, which will be on your formula sheet for AP Bio. I'm going to go to a place where it is. Okay, so here's our chi-square table. This is not like a super great image of this, but we're going to look always at this 0.05 section of the chart. And then for this problem, we had 3 degrees of freedom because there were 4 possible phenotypes. And that means that our degrees of freedom is 3 because your degrees of freedom is always what you have minus 1, so 3. So the number we're looking at as our value to determine whether we should accept the hypothesis or not is 7.82. If we're below 7.82, we can accept that the hypothesis is true or fail to reject. If it's above, we reject the hypothesis. So we're going to go back to our problem here, and we're going to reject because we're above. So reject hypothesis because above critical value of 7.82. And so then I'll say 3 degrees of freedom. Okay, there you have it. So in summary, when you see a problem like this, the first thing you need to do is you need to find your expected values using a Punnett square or using the ratio that you already know. Then you use your total number. It might not give you the total number. You might have to add them all together to get your total to find your actual expected numbers of organisms, whatever it is. They should be regular whole numbers, not fractions. Then you just go through the steps. So observe minus expected, square, divide by expected, and then add it all together to get your final chi-square value. Finally, you go back to your chart, which will be on your formula sheet. Look at the degrees of freedom that make sense for your problem. If you only had 2 phenotypes, you would look at 1 degree of freedom. You look at the row for 0.05. And then if you're above, you reject. If you're below, you fail to reject, which means that the differences that exist between the observed and the expected values could just be, and probably are. So there you go. If you have more questions about chi-square before Wednesday when we do FRQ, just let me know and I will be glad to assist you. Thanks.